Meteorites hold a special place in astronomy because they represent basically the only part of the universe beyond Earth that we can actually touch. Everyone has a story to tell, but some of those tales are more curious than others. So here are 3 of the weirdest meteorites we've ever found and what we learned from them. Our first example isn't actually just one meteorite, but a whole category. About a quarter of all meteorite samples show certain distinctive signs of being sculpted by the atmosphere as they fell to Earth. The most striking have a special cone-like shape scientists call oriented meteorites. After the white-hot intensity of hurtling through Earth's atmosphere, most meteorites end up looking like weird chunks of rock. But the oriented ones are kind of comparable to the conical nose of an airplane. You can tell which way they were pointed as they fell. Astronomers have known about oriented meteorites for a long time, but they didn't really know how this cone shape formed or why it only happens some of the time. But a paper published in 2019 has finally shed some light on the situation. The researchers recreated the flight of a meteorite, but instead of using a lump of rock falling through the sky, they used lumps of aluminum falling through water. And cone-shaped lumps tended to fall in a relatively straight path without fluttering or tumbling. This tells us that once they'd been eroded into a cone shape, oriented meteorites had relatively stable trajectories as they traveled through the atmosphere, letting that cone shape remain intact. But that kind of path isn't guaranteed. Most of the time, things tend to tumble head over heels. So how did these meteors remain stable as they fell? The authors also found that if an incoming meteor has an angle that's too narrow, it bounces around, causing it to break up or erode too unevenly to form a cone. And if the angle is too wide, it'll end up fluttering back and forth like paper falling through the air, which also leads to uneven erosion and no pretty cone. Only if the nose makes an angle of about 60 to 100 degrees will it fly straight the whole way down and become an oriented meteorite. But meteorites aren't just space brought to Earth. They're also pieces of the past that have survived to the present. One group, called the l-chondrites, is particularly intriguing because they all seem to have come from the same parent body at about the same time. And this isn't just a few samples. Nearly all known meteorites are classified as chondrites, and up to 40% of those are l-chondrites. Many have been found in southern Sweden, embedded in limestone that's about 470 million years old. One meteorite from this region, though, sticks out like a sore thumb. It's called Esteplana 065, and not only is it not an l-chondrite, it doesn't resemble any other known meteorite. One way to differentiate between meteorites is by looking at the isotopes of the elements it contains. Isotopes are atoms of the same element with a different number of neutrons in their nuclei. The ratio of different isotopes in a substance works kind of like a fingerprint to identify where it might have come from. When scientists examined the oxygen and chromium isotopes from Est-65, they found ratios very different from the l-chondrites or any other known meteorite. That suggests that Est-65 comes from a totally different space object than other meteorites we've recovered. So if it's so different, why was Est-65 found mixed in with a bunch of l-chondrites? Scientists think that if the l-chondrites all came from the same destroyed asteroid, Est-65 might be a chunk of the object that did the destroying. They collided violently in space, only to rest in peace together here on Earth. Our final meteorite is unique for both how we found it and what it was hiding inside. It's called Amahatasita, and it was the first meteorite to be detected before it hit Earth. Astronomers even predicted approximately where it would land, which allowed geologists and volunteers to find and pick up the fragment. And when they cracked open some of the pieces, the scientists found giant diamonds hiding inside. Well, not giant diamonds, but bigger than they would have expected. See, diamonds in meteorites aren't actually that surprising. Asteroids often contain carbon, and microscopic diamonds are created all the time as they slam into one another. But a sudden impact can't form a large diamond. For that, you need lots of pressure over long periods of time, like the conditions you find deep inside a planet. Diamonds often contain impurities in the form of minerals trapped inside their structure. Since we know how these minerals form, we can infer what conditions were like where the diamonds were forming. For instance, quartz crystallizes at a relatively low pressure and temperature, while olivine forms only under extreme conditions. This is just because they're made out of different stuff. Some minerals can even take on different structures depending on the conditions of their formation, That's why we have both diamond and graphite, even though both are entirely carbon. Almahata-Sitta contains chromite, some phosphate minerals, and some iron-nickel sulfides. Their chemical structures could only form under a pressure of at least 20 gigapascals, which is really high. That tells us that the object they formed inside was likely at least the size of Mercury, or maybe as big as Mars. Since Mercury and Mars are definitely still around, Almahata-Sitta probably came from inside a primordial planet that was destroyed in the chaos of the early solar system, a planet that never quite made it, which makes this rock from space as old as the Earth itself. So the next time you look up and see a shooting star, just think, hey, that thing could be chock full of diamonds. Or maybe not. But either way, it could teach us something we never knew before. Thanks for watching this episode of SciShow Space. Before you go, since you're here and we know you like space, we'd like to draw your attention to September's DFTBA Pin of the Month, which is this awesome retro take on the Viking lander. This is a pre-order for a pin that will ship in October, and once September ends, they're gone forever. So get them while you can. But don't worry, we'll have another great space pin next month. Check it out at dftba.com or the merch shelf right below this video.